Hello, more practice exam questions and vectors and determining whether or not the line L that has an equation such x plus 2 over 1 is equal to y minus 5 over minus 1 is equal to z minus 4 over minus 3 intersects the plane with equation r dot I minus 2j plus k is equal to minus 7 at a single point, or lies in the plane or is parallel to the plane without intersecting it. Well, the first thing that we need to do is to get this Cartesian equation in vector form. So we're going to use, of course, r is equal to a plus a lambda b, and using that we're going to have our line L in x, y, and z form, vector form. Put everything in vector form, and that will be equal to, well, I always say that the numerators equate it equal to 0. So we've got x plus 2 equals 0. So we've got minus 2, y minus 5 equals 0. We've got 5, and z minus 4 equals 0. We've got 4. So minus 2, 5, and 4 is a. And then plus lambda b, and that's all your denominators, which is 1 minus 1 and minus 3. That's how I teach it, and it seems good to go. Right, now we have our x values then of minus 2 plus lambda times 1, which is minus 2 plus a lambda, and our y value is 5 minus lambda, and z will be equal to 4 minus 3 lambda. And yeah, I'll put that in brackets because that's my x, y, and z. I'm going to use those later on. Now, though, I'm going to use the equation of the plane. Using the equation of the plane, and what is it? Let's go back. We have it as r dot I minus 2j plus k is equal to minus 7. So let's write that out. Using the equation on the plane, r dot I minus 2j plus k is equal to minus 7, and I need to put that in vector form, so x, y, and z, and because we are going to do a dot here, and of course the coefficients of I minus 2 and 1, so that's coefficient of I is 1, and then we got minus 2 and 1, so there you have it. And oops, I'll put a dot here, and of course that's equal to minus 7. So moving on, I'm going to substitute now, and I did say I was going to use those values. Substitute the values of oops, I've missed out a bit. Hold on, let's go back. I've missed out a bit because I need to write out my equation. X times 1, that gives me x minus 2y plus z, of course, is equal to minus 7. Now, I'm going to substitute the values found earlier. What values are those? X, the values of x, y, and z. I'm going to substitute these values into the equation. Substitute x, y, and z found earlier into x minus 2y plus z is equal to minus 7. And when we do that, we're going to get, well, the value of x found was minus 2 plus lambda, and the value of y was 5 minus lambda, And we got two lots of that, and the value of z found was 4 minus 3 lambda. 4 minus 3 lambda, and it's all equal to minus 7. So, tidying that up, that gives me minus 2 plus lambda, minus 10 plus 2 lambda, plus 4 minus 3 lambda is equal to negative 7. Now, we can see that minus 2 minus 10 is minus 12 plus 4. That gives me minus 8. And I've got lambda plus 2 lambda is 3 lambda. My lambdas have gone. So I've got minus 8 is equal to minus 7. Now, that may not add up. And it's not supposed to, because what that tells us is that there is no intersection. So, because if there was an intersection, they'll be equal to one another. So the fact that it's minus 8 is equal to minus 7, which perhaps doesn't make a lot of sense, there is no intersection. So I can say, therefore, no intersection. No intersection. There's no intersection. And the line, we know that the line then, the line is parallel to the plane, but not in it. But not in it. But not in the plane. So, but not in it. Because we've got no values for lambda, and we've got left-hand side not equaling the right-hand side. So there we have it for 5 marks, I believe. 5 marks.